I'm going to solve a numerical problem related with pressure, and I have taken one of the numerical problem of SLC board of Nepal of class 10. Look at this. An ice block of length this much, breadth this much and height this much is taken. It is floating on water. Like this, ice block is floating on water. What portion of the ice should be outside the water if its density of ice is this much? This is the portion of ice outside the water. We are going to calculate the portion outside the water. For this, actually we have to know that total volume means volume of ice, total volume, that is volume of ice is this whole, and the volume inside the water is this much volume. This can be taken as volume of displaced water by ice. And if we take the ratio of these two, then part of the ice inside water comes. It means this is part of ice inside water. This is part of ice inside water. And if part of ice inside water is this much, then part of ice outside water will be equal to 1 minus B water upon B ice. Now our target is to find out this part of ice outside water. This is 1 minus B water upon B ice. For this, I want to start from principle of flotation. Principle of flotation says that in every floating body, weight of floating body is equal to weight of displaced liquid. So I want to start from this. We can use this equation for every floating body. According to principle of flotation, according to principle of flotation, weight of floating body, in our case it is weight of ice, is equal to weight of displaced liquid. In our case it is weight of displaced liquid, weight of displaced water. We can write symbolically, shortly, weight of ice is equal to weight of displaced liquid, means weight of displaced water. W equal to mg, weight equal to m into g. M into g means mass into acceleration due to gravity. That's why weight of ice can be written as mass of ice into g equal to weight of displaced water can be written as mass of displaced water into g, and g cancel. Now mass of ice is not given, that's why I can write this way also, density of ice into volume of ice is equal to, here also, density of water into volume of water. How can we write so? Because we know that density equal to mass by volume. It means mass is equal to density into volume. Look at this, density equal to mass by volume. Mass, if volume is taken to left hand side, mass equal to density into volume. So in place of mass of ice, I wrote density into volume. Density of ice and volume of ice. In the same way, mass of water can be written as density into volume. Okay, now our target is to find out B water by B ice. So B water is in right hand side, B ice is in the left hand side. I want to take this to right hand side. We can do this way. Density of ice, and D water is, if taken to left hand side, it comes density of water here is equal to volume of water upon volume of ice. And D ice is given, density of ice here it is given 0.75, and density of water we know 1. Volume of displaced water and volume of ice ratio can be written as part of ice inside water. That's why part of ice inside water is equal to this much. Now next, part of ice inside water is equal to, now point is, if taken to 2 digit right hand side, we can take 20 here, so it becomes 75 upon 100, 25 3s are 25, 4s are 100. This is 3 by 4. If part of ice inside water is 3 by 4, then part of ice outside water will be 1 minus 3 by 4. This is equal to 4 is, if taken as LCM, then 4 minus 3. This is equal to 1 by 4. This way we can say that out of 4 parts, 1 part is outside the water. 1 by 4 is outside the water.